Hello everybody, today we want to introduce our Simulate final project. We're using system simulation for modeling online game, DragonNet server. Our teacher is Ong Shaoren, and our teammate is Lin Jiaxian, Zhang Jiarui, and Zhang Junrui. Then let me say our outline. First, we will say summary, and then motivation, objective, and original process, and the original model. And then we will say new process and new model. And then we will make data analysis. In the end, we will make our conclusion. Now we want to introduce our project simply. DragonNet is an online game. Because of its special rule of FTG, and in rush hour, there are too many people were waiting to enter service, and we want to solve the problem. So we try to find a new process to improve the problem, and then we want to introduce our motivation. Why we want to do this project. DragonNet is a lately famous online game, and so many people want to play the game, but they can enter the server because the servers are limited. There are some people need to wait for entering service, and then there are a special rule in DragonNet. It is fatigue. Every player's rule only has 700 fatigue, and different barriers will consume different fatigue. When fatigue turns into 0, the player needs to leave the DragonNet. And then we know customer certification is so important for online game companies, and we know need to avoid the players waiting for a long time. And then we want to introduce our objectives. What do we want to do? We want to realize operation of DragonNet and to model DragonNet servers and to improve process, and then more people can join the game, and to analyze the benefit results.
And this is how we build our model. First of all, the player will log in DragonNet. Then he will choose the server in his role. Then get in the village. And he can choose whether he wants to play by himself or join a team play. Then they go into to break a barrier. And when after the barrier, they will close their FTG. If they still have enough FTG, they still can get back to the village and play the next barrier. If they don't, they leave the DragonNet. So we use those things to build our model and to simulate the real system. And our arrival distribution depends on time. So different time can cause different people to join the server. And there is different probability to choose their different roles and choose whether they want play by themselves or they want a team play. Then we use those levels to collect our data, like how many times they trying to join the system, and how many FTG do they still have, and what is their job, and what's their playing type, and which map and where to go. We use those levels to collect this data. Then we use visual logic to decrease our FTG, and use visual logic to count how many times they waiting and how many times they waiting in the barrier, and do they leave the dragon nest or not. Then we talk about object function. We use resource to count how many players in this server, and we can collect the resource back if they leave the server. And we use course shell life to see how many times did they wait in the core, and if they wait so long, they can leave right away. And we use work centers routing in and routing out by label base very often. So this is our Dragon Nest original model, and there is the arrival, and arrival follows a distribution. In fact, there is several distributions. If the time is rush hour, the player join the game very fast, and there are thousands of people will join the system immediately, and they will go into the core, and they will wait for join the system. And here is our system entry. If they want to go in the system, they need a resource. If they don't have a resource, they have to wait outside for a while. If their waiting time is bigger than 5 minutes, they will leave for a while, and after a while they will go back to the core. And if they leave the core for 3 times, they won't go back again. After they join the server, they can choose their job. In fact, the player prefer to choose warrior and a priest. Then they go to the village. At the village, you can choose whether you want to play by yourself, and you can choose the EP way. And if you want to play in the team play, you can go to this way. And if you want to play by yourself, you go to the barrier and choose what barrier you want to play. And each barrier has their FTG cost and will spend different time to play. And if you choose your playing time, you finally will play here. And here we use the function is shell life. The shell life is count on how much level did you get here. And the same situation is if they choose to play in the team, this might mean they want a team that consists of 1 warrior, magician, priest, and archer. So they will wait in each 4 core. If they have if each core has one player, So they will combine the team in one and go to the next barrier and choose what barrier they want and go to the game player zone. And if they wait for so long time, they will go back to the village. After they choosing the barrier, they will go into this court to play, and they will stay for a while. How long will they stay? It depends on the level they get at each barrier. It has different value. And next stop, this stop is for costing your FTG. Your choose will cost different FTG cost. Then go to the FTG test. If you still have enough FTG, you will go back to the village. If you don't have enough FTG, you might leave the system immediately. Our improvement is to add this way for the team player to go, because some team players don't care about if they get 4 jobs in the team or not. So this way is for the players, just want 4 players play together. So if we get 4 people here, then we go to break the barrier. Then in the new model, if the team player waiting for so long time, they will go back to the fast in stop, and they will go to this court. And if they have 4 people, they go to play the barrier.
Let me show you the data analyze. The data analyze according original, we see the improvement, and after improvement 1. Original 1, we can see the player leaving without play is at 5 people, and those 5 people waiting to enter the server. Then we talk about after improvement. They are leave without play. Then we talk about the people finish the game. We can see before the improvement there are 2,758 players. If finish their FTG and leave the system. After improvement, the player finish the FTG and leave the system more than before improvement. Attention to the every time they play in the system is 39 minutes. We almost decrease 40% every time in the system after improvement. And the conclusion, the difficult problem that we face to is there are so many things have to consider, and when modeling has so many objects, so we have used so much time to wait it finish. And the result, we can see the new process can make the player phase 2 enter the server, can let much people can play the game.